Welcome students. This video is going to run through the application task for 2020. This was used to assess students with looking at the actual assessment. We've got an introduction here that says the table provides data of a town in Victoria regarding its daily weather observations in July 2019. This application task will investigate and analyze this data. So with this data here, what you need to do is, before you even start this particular SAC, just make sure you understand what data is actually presented. This is something that should be done during reading time. You can see that you've got date, week, minimum temperature, maximum humidity, wind speed, rainfall, hours of sunlight, and this is the number, this is the percentage of dry days versus wet days. And let's look at the first question. The first question here says, the Bureau of Meteorology, the weather people, have asked you to find out whether the town was affected by the national drought in 2019 through investigating rainfall and max humidity. From the data provided, identify one heading that is categorical and explain why. So if we go back to our understanding of what a categorical variable is something that can be organized according to its characteristics. And sometimes I think the trick is that numbers can also be organized into categories as well. For example, the date, even though it's represented in numbers, date is actually a categorical variable. Same with week as well. The one way I like to think about this is that if you found the mean value of the date, that would serve absolutely no purpose whatsoever in actually explaining the data. If I said to you the mean week, when I say mean, I mean the average, that would actually bring no significance to you. So that's one check that you can use to see whether or not it is a categorical variable or not. So for this question here, the data provided, date or week is the categorical variable. Now, it says explain why. The way you should be representing this is they are categorical variables as they represent categories rather than quantities. They cannot be measured or counted. Okay, and that in itself would get you the full mark for this. Alright, moving on to the next question. It says, a dry day is defined as a day when no rainfall is recorded. Construct an appropriate display to show the distributions of dry and wet days. You might choose to use a blank table or a graph below. So what we need to do is we need to have a look at the data and investigate this column right here. Now this column right here will tell us whether or not it was a wet or a dry day. Now the dry day is when no rainfall was recorded. Every other day is a wet day. Okay, so the way I like to think about this is we're defining it in terms of two variables. It's either going to be a dry day or a wet day. Okay, and from this data, we can actually just calculate, well, firstly, there's 31 days. Okay, there's 31 days in total, because it goes up to 31. We just need to calculate now how many of them were wet and how many of them were dry. So how many zeros do we have? So we've got 6, 7, 8, 9, 10, 11, 12, 13, 14. We've got 14 dry days. Okay, and the number of wet days we have, well, it's going to be 31 take away 14, which is 17. Okay, so now we need to find a way to represent this data in some sort of meaningful way. We've got wet and dry days, so if we go to our graphs, we've actually got a categorical variable. Okay, and we're trying to measure that against another categorical variable, which is the days. So we should probably use a segmented bar chart or a side-by-side bar chart to actually represent this data. So let's go down and actually put the data in first. So the way I would represent this is by saying wet goes here, dry, total. This would be frequency, and this is percentage, and this represents the number of the days in itself. So let's do a quick transfer of data. The dry is 14, the wet is 17, and the total is 31. So we can work out the percentages for these ones by going 17 over 31, times it by 100. This one can be 14 over 31 times 100. And this one here should be 100% because we've got all the data. Okay, so that one's a given. So if you run this through your calculator, 17 over 31 times 100, that should give you 55%. And the number of dry days should give you 45%. Okay, so we've achieved about half the mark so far. Now we need to represent this, we could represent this in an alternative way, because this is technically I guess a display of data in itself. Okay, you don't need to do two things, but if you prefer to do two, you don't actually get any more marks on that one. So another way we could actually represent this graph is by showing a bar chart or a segmented bar chart. So you can see with this diagram here that we've got two different bars. One goes to 14, one goes to 17. Or you could draw a segmented bar chart where the total should be up to 31, and 17 of that goes to wet days, and 14 of that goes to dry days. So this is where the open-ended nature of it comes into play, is that it's not the be-all, end-all with how you interpret the question with some of these. Now the next question says, what conclusion can you draw from the above display? So I guess the thing that you need to understand is that if there is a difference between the data, if there is a significant difference between the data, when I say significant, generally in the exam you'll have a significant number. For example, if this is 70 and this is 30%, okay. If there is a difference, there is an association. Okay, so difference implies an association. In this case, you could actually argue one or the other. You could say that this display shows an approximately equal distribution. Hence, there is no association between days and the dryness and rainfall. Okay. And you should probably note down here as well, wet is 55% and dry is 45%. Or you could also argue the opposite, that there is a difference. This display shows a 10% difference between the wet, which is 55% of the days, and dry, which is 45%. Hence, since there is a difference, there is an association between days and rainfall. Okay. Next question says, identify any outliers in the data of rainfall using calculations to support your answer. Now, in doing this question here, I suspect a lot of you guys would actually plug in your data into the CAS before you even do any calculations. And I think that's quite appropriate because we need to know what kind of if we are going to be looking for outliers or not. So let's start a new document here. I'm running around in circles. So, data rainfall. Let's take the rainfall data, and unfortunately you guys will need to make sure that you do this very carefully on your CAS. Fortunately I've got the luxury of using a computer. Copy paste, and this is rainfall. Okay, so to turn this into a graph, control menu, quick graph, split the screens, control 6, and then control right. Alright, we can't really tell if there's an outlier here at the moment, but we can go menu, analyze, menu, plot type, box plot, and voila, you've got 3 different outliers here. So we should be cognizant of the fact that when we do our calculations, there will be outliers. Now, instead of going back, I know one of the standard ways that you could probably work out the next few bits, because you need the IQR, is by going menu, statistics, stat calculations, one variable statistics, okay, and working out what the Q1 and Q3 are. But if you actually look at your graph, you don't need to do all this, because if you hover over it, you can see the max value is right there, 8. The end of the tail is 5.2. Q3 is 2.4, median 0.2, and Q1, and looks like the minimum is also 0 as well. So you don't need to actually redo that analysis. It's all right there. So let's calculate this now by calculating the upper fence. I should probably do lower fence on the left because that would make sense. And then also the upper fence. Okay, so the lower fence calculation is Q1 minus 1.5 times the IQR. And QU is Q3 plus 1.5 times the IQR. And the IQR in this case is equal to Q3 minus Q1. And Q3, if we look at our data, is 2.4. And Q1 is 0. So the IQR is 2.4. Alright, so let's plug in a couple of values now to aid with our analysis. So Q1 is 0 minus 1.5 times 2.4. And Q3 is 2.4 plus 1.5 times the IQR, which is, 2.4. Yep. And so our lower fence will be, let me just calculate it really quickly. Our lower fence is negative 3.6 and our upper fence is 6. Okay, so now that we've got our upper fence and our lower fence, let's investigate our data and see if anything is less than negative 3.6. No, so nothing is less than negative 3.6, which means that there's no lower outliers. What about the upper outliers? Do we have any larger than 6? We've got 1, we've got 2, and we've got 3, and I think we've got 4. So it's actually revealed that we've got 4 outliers, despite the graph showing only 3. So please make sure you double check this, because you can see that's quite deceiving there. You would say, therefore, 4 outliers as 8, 6.4, I think it was. 8, 6.4, and 6.8. Are greater than 6 upper fence. Okay. So there's multiple ways you can interpret that last sentence, but just as long as you make that statement that there are outliers, how many there are, what they are, and if they're upper outliers or lower outliers, you've done your job with that one. Okay, next one, it says complete the following table for the statistics of max humidity. Alright, so max humidity, let's get our data. Unfortunately, you guys will have to do the same thing again when you input the data. But I luckily have the luxury of copying and pasting. Oh, no, go away. So I'm going to start a new tab. Actually, why not? Okay, I guess this is good to talk about here. And if you have this kind of data, it might be because you need to change your document settings. So documents, setting status, document settings, auto. For this case, let's change it to approximate. Okay, so unfortunately, when I copied and pasted it, I got the decimal value. So I'm just going to do a bit of fancy footwork here. Just give me a moment. Alright, so I've got my data here for max humidity, which is now represented as a percentage. And I'm going to calculate the statistics for this. So this is where I would probably do the statistical analysis by using this method. So menu, statistics, stat calculations, one variable statistics. We want to calculate one list, and we want to make sure we calculate the max humidity. Okay, and now we've got our summary right here with us. So our mean, this is the mean with X bar. That's 85.48. Okay, generally you want to make sure that your rounding is consistent. You want to make sure that you don't have alternative. If you're going to do rounding to 2 decimal places, you round everything to 2 decimal places with these summary statistics. The standard deviation is SX. Do not use sigma X. We want to use SX. That would be 8.17. Okay, so we round it. Minimum value. Minimum value is min. So actually, we've got our statistics here. We've got 71, 79, 85, 93, 99. IQR is the difference between these two, which gives us 14. And the range is 28 because this is the max minus the min. Okay, so let's look at this graph now. Let's turn this data into a graph. So menu, quick graph. So control menu, quick graph, control 6, control right. Max humidity, plot type, box plot. Okay, so this data here is a little bit, it's a bit tough to talk about because the mean and the median itself, okay, is the mean an appropriate measure of center for max humidity. Remember that if there is skewing or there are outliers, mean is not an appropriate measure. So I'd actually straight off answer that right now. I'm going to talk about the flip side in a moment. So I would say not appropriate because the distribution is positively skewed. Okay. Therefore, the median is a more reliable measure of center. Okay. However, you could also argue that it is appropriate because of the fact that the mean and the median are very close to each other. It's only a matter of being 0.48 off. So you could say, or appropriate because despite the fact it is positively skewed, the mean and median values are, I guess you could say, approximately same in similar in value. Okay, you would say mean is 85.48. Median is 85. Okay, and I'd also make sure that you always state the actual number whenever you quote, the median or the mean in this case. All right, let's keep going. The Bureau of Meteorology intends to compare max humidity to dry. Max humidity on dry days to it on its wet days. Choose an appropriate graph to display max humidity data on dry and wet days. So we've got dry and wet days. So we've got two categorical variables, and we're trying to compare max humidity. So these two are categorical, and max humidity is numerical. So which graph should we use? Let's open up our template here. We've got a numerical and a categorical. Numerical, categorical. Ooh, we've got parallel box plots. Okay, we could use parallel dot plots, but I think box plots is more of what we've learned so far. So let's look at the data now. Max humidity and dry and wet days. So the way I would approach this is put this data into a spreadsheet. So I'm going to start a new spreadsheet, so menu, page, spreadsheet, and I'm going to call this dry, and I'll call this wet, because we want to separate the two from each other. And I'm going to put all the dry days in one column, and so I'm going to highlight these as the ones that we want, because these are all aligned with 0. Okay, all the ones that have 0 we align. Okay, so I want to input that data into the dry column, because remember, dry means 0 rainfall. Okay, I'll have to do the changing in a moment. It's alright. Just do what you need to do with this. Make sure you input it as actual percentages. And the last 3. And the 14th one is there. Okay. So I've got all my percentages. Now I'm just going to put in the wet days. So the wet days is everything else. So all the other days. And we want to make sure we've got 17. Yes, we will have 17 by the end of this. Okay, so at this point we've separated the dry and wet days from the max humidity column. I'm just going to do a bit of fancy footwork and turn this into percentages in just a moment. Alright, so now that we've got the actual percentages for these days, let's turn this into a box plot. So control, menu, quick graph, control 6, control right, and we're going to turn this into a box plot, plot type, box plot. Now this is what you need to do if you want to put two box plots on one, because we've only got the dry percentages on there at the moment. You hover over your bottom or your explanatory variable, control menu, and you want to add an X variable. And the X variable that you want to add is wet percentage. Okay, at this point you've actually got your graph here. You just need to make sure that you label it appropriately in this section here. So I'm actually going to take a snippet of this and paste it in. Now, you'll have to make sure that when you draw this up, there's a couple of things you need to make sure that you mention and also include. One is labels. You need to make sure you've got the labels. You've got the key. Okay, you've got the title or the categories. Okay, and obviously the scale. Okay, scaling needs to be accurate. This one here just needs the labels of percentage of days. Percentage of days, I think that's what it is. Okay, now the other one you could do is represented as a dot plot, but I wouldn't bother at this point. You could also represent this as a stem and leaf plot, but at this point, all we need to do is just answer the next bit. Why did you use two box plots and compare them against each other? Well, a categorical variable, which is the wet/dry days, is compared against a numerical variable, which is max humidity. Okay. Alright, next bit says compare the distributions in terms of shape, center, outliers, and spread, quoting relevant statistics where appropriate. Keep in mind in future SACs, this might not necessarily be implied, it's not going to be explicitly mentioned. However, if you're asked to find the relationship between two variables, you just need to make sure that you compare them according to shape, center, and spread. Okay, now with the center, there's more appropriate measures that we should use for both of these. So let's answer these now. The shape. Wet days is positively skewed. And has no outliers. Okay, you could also include the outliers as a separate section. However, you can also include in shape. Dry days. So, whereas dry days is negatively skewed and has no outliers. Okay. The center, we should probably use the median, because remember we discussed in earlier questions that if you've got a skewing, the median is a more reliable measure. So the median of the wet days is 83%, which is lower than the median of the dry days, which is 89%. Alright, now the spread. Okay, since there's skewing, we should probably use IQR. Range would be accepted in this one because there is no outliers, or there are no outliers, but I generally stick to the IQR. So the IQR for the wet days is 10%, while the IQR for dry days is 13%. Actually, I wouldn't even include here, which is lower than the IQR for dry days, which is 13%. Okay. Now, I need to emphasize again, you can also state outliers as a separate thing. However, this is perfectly acceptable as well. Okay, the last one is, with reference to appropriate statistics, is there an association between max humidity and the presence of rainfall? Remember, whenever it says association, we need to remember the word association implies if there is a difference, there is an association. So I would say there is a significant difference here, because this one here has a median of 83% and this one has a median of 89%. So I would say yes. Yes, max humidity has a median of 83%, which is max humidity is a median value on wet days, which is significantly lower and compared to 89% of the dry days. Okay. Now, when we're talking about reliability, or so the association as well. Okay, we could also mention the fact that these variables, this one here is 10% and this one here is 13%, which means that the dry days were more variable. You could also add in the comment here. However, the wet days were more variable than the dry days, as the IQRs were were 13%. So wet days were 10%, 10% and 13% respectively. Alright, so that ends part 1 of the SAC. Second video we'll go through the second part, which is going to be talking about bivariate or regression analysis.